On the drawing boards of the Third Reich, it was the ultimate weapon. An armored behemoth, a machine so heavy and so powerful it was designed to be impossible to destroy. This is the Panzerkampfwagen 8 Maus. Tipping the scales at an insane 188 tons, it carried a cannon the size of a small tree, and its armor was nearly half a foot thick. Hitler believed it would be a game changer, the tank that would sweep the battlefield and crush the Soviet advance. But the Maus never fired a shot in anger. The question is, why did the biggest tank ever built become nothing more than a giant paperweight? The answer starts with one man's obsession. By 1942, the war on the Eastern Front was becoming a desperate grind. The massive Soviet T-34 was already a profound shock to the German Wehrmacht. Hitler's solution was not better logistics or more efficient production, but simply more size. This was the dictate of size. Hitler believed that the sheer scale of a weapon would demoralize the enemy and compensate for German industrial limitations. We saw this same philosophy in the Bismarck battleship and the monstrous Schwerer Gustav railway gun. The Maus was the tank version of this psychological need for invincibility. The specification Hitler personally approved was simple: maximum protection. The engineer's goal wasn't to outmaneuver or outflank the enemy, it was to build a moving fortress that was physically immune to all known anti-tank weapons. Let's look at the numbers. The frontal hull armor was a staggering 220 millimeters, that's almost 9 inches of high-grade, rolled homogeneous steel. To put that in perspective, the entire weight of the standard US M4 Sherman tank was roughly 30 tons. The Maus carried 7 times that weight, mostly in its armor. But armor is only half the story. A fortress must have a cannon. The Maus was outfitted with a terrifying main gun. This weapon was a direct evolution of the powerful anti-aircraft and anti-tank cannons already in use. At standard combat ranges, this cannon could theoretically pierce the armor of any Allied tank, including the heaviest Soviet JS-2, with ease. Its power was unrivaled, and in a unique and utterly complex touch, a smaller coaxial cannon was mounted alongside it. It was, on paper, a brilliant piece of engineering, a masterpiece of defensive and offensive power. But this is the moment the blueprint stops and the nightmare begins. The sheer ambition of this design created an impossible challenge that would cripple the entire project. The demand for the Maus forced a strange partnership between two giants of German industry, the brilliant but unconventional designer, Professor Ferdinand Porsche, and the massive industrial powerhouse, Krupp. The development of the Maus, or Type 205, as Porsche originally designated it, was a constant battle between design theory and battlefield reality. Porsche, a genius obsessed with innovative, complex solutions, was determined to use a revolutionary drive system. Porsche rejected the traditional mechanical gearbox used in virtually all other tanks. Instead, he chose a diesel-electric transmission. The idea was to take a large surplus U-boat engine, a V12 diesel, and use it not to directly drive the tracks, but as a generator. The engine produced electricity, which then powered a separate electric motor for each track. On paper, this offered incredibly smooth and powerful torque, perfect for moving a mountain of steel. In reality, it was a profound disaster. The sheer weight of the Maus constantly overloaded the motors. In testing, the electric drive system had a catastrophic tendency to overheat, short-circuit, and simply break down. The engineers were continually struggling to cool the motors, adding extra weight and complexity to a design that was already far too heavy. While Porsche was battling electrical physics, the Krupp manufacturing plant was facing an impossible industrial challenge. For years, the German war economy had focused on mass production of tanks like the Panzer IV and Panther. The Maus was the exact opposite of mass production. Casting the immense hull and turret plates required colossal furnaces and cranes that were needed elsewhere for vital war production. The time and resources needed to create just one mouse chassis could have built dozens of crucial, faster, and more effective tank destroyers like the Jagdpanzer IV. This internal war between Porsche's obsession with high-tech complexity and the logistical realities of the Krupp factory resulted in a machine that was too heavy for the chassis, too complex for the battlefield, and too costly for a dying war economy. The failures were compounding. In December 1943, the first prototype, the V1, was ready for testing at the sprawling proving grounds of Kummersdorf, south of Berlin. The sight alone was staggering. But the shock wasn't its size, it was its pace. This ultimate weapon of war moved at a geriatric crawl. The mouse could manage a top speed of 13 miles per hour on perfectly paved roads. Off-road, traversing soft terrain or hills, it often struggled to reach 5 miles per hour. The problem was fundamental: ground pressure. Think of the entire weight of a large house resting on two small rectangles. That's the force the mouse exerted. Driving it across anything other than concrete risked the tracks digging in, becoming instantly bogged down, or simply tearing up the ground beneath it. Even if the terrain was cooperative, the infrastructure was not. The 188-ton monster was too wide for any standard German road, and certainly too heavy for any bridge. German bridges were rated for tanks like the Tiger, around 50 to 60 tons. The mouse was triple that. Every river became a crisis. This dilemma led to one of the most absurd technical solutions in tank history: the deep wading system. Since it couldn't drive over bridges, it would drive under them. The plan was for the mouse to drive submerged along the riverbed, breathing through a giant snorkel tube. But this required two things. First, waterproofing every single seam and hatch, a monumental feat. Second, it required two mouse tanks working in tandem. The mouse simply didn't have the engine power to move itself in the water, so its twin had to power it from the riverbank. This absurd operation was highly risky, easily defeated by enemy fire, and perfectly illustrated the tank's inherent flaw. It required more resources to move than it was worth in combat. And then there was the issue of fuel. Germany was running on fumes by 1944. The mouse was an ecological disaster waiting to happen. It consumed fuel at an astronomical rate, roughly 1,000 liters of gasoline for every 100 kilometers traveled. It couldn't keep up with the war. It couldn't cross a river without help, and it drank Germany dry. The tests at Kummersdorf confirmed that this machine, intended to be a weapon, was instead a logistical anchor, an industrial black hole, and a complete strategic liability. By early 1945, the Soviet Red Army was closing in on Berlin. The grandiose plans for a massive fleet of invincible mouse tanks had been reduced to just two prototypes: the finished V2 turret and the partially completed V1 hull. Despite the desperate state of the war, these tanks, or at least the technology inside them, were still highly valuable. Hitler ordered the prototypes moved to the Winsdorf military base, where they would supposedly be used in the final defense of Berlin. This was a tragic joke. The mouse wasn't built for street fighting or rapid deployment. It was a positional weapon for a war that Germany had already lost. Its final, ignominious fate was sealed just south of Berlin at the Kummersdorf testing ground, where it had spent years failing its trials. On April 20th, 1945, with Soviet forces just hours away, the crews received their final orders: scuttle the prototypes. The war's most expensive, over-engineered weapon was to be killed not by an Allied shell, but by explosives, planted by its own desperate crewmen. This was the final, profound irony of the project. The tank, designed to be immune to enemy fire, was ultimately destroyed by the failure of its own command and logistics. Its existence was terminated by the very people who had devoted their careers to building it. When the Soviets overran the area, they found the two abandoned, shattered prototypes. Recognizing the propaganda and intelligence value, they undertook a monumental task, salvaging the wrecks. They carefully recovered the V-1 hull and the V-2 turret, combining them to create one complete functional Maus. This salvaged Franken tank was shipped back to the Soviet Union for exhaustive study, eventually landing at the Kubinka Tank Museum near Moscow, where it sits today. Its value to the Soviets was purely in teaching them what not to do. The Maus became an evolutionary dead end. It confirmed the principle that would define post-war tank development. Mobility trumps protection. A tank that can't reach the battlefield is just an expensive bunker. The truly successful tanks of World War II, the Soviet T-34 and the American M4 Sherman, were not the most heavily armored, but they were reliable, easy to repair, and could be produced by the tens of thousands. They overwhelmed the enemy with sheer numbers and efficient movement. The Maus, by contrast, represented the hubris of a regime obsessed with mythical superiority. It diverted irreplaceable resources and engineering talent away from practical, war-winning weapons. The entire project was a tactical deadweight and an industrial black hole. Today, the Panzer VIII Maus is a powerful visual spectacle, a monument to metal, ambition, and failure. It stands as the ultimate historical lesson that in warfare, as in engineering, complexity and size rarely beat efficiency and mass.